Hey guys, so we're going to move into something that I'm calling acid information. Note for you, just in case, most of this information is not going to be on the test. It is provided for your information only. So things that we have to talk about are types of acids. So we can talk about hydrohalic acids, so HCl, HBr, HI. Those are great acids. HF is not, but that's made from a hydrogen and a halogen. It's called a hydrohalic acid. We also have things called oxoacids. They contain HO and something else. All right, CH3COOH is an oxoacid. Okay. We also have things called carboxylic acids. All right, they have some R group attached to them, and then there's a carbon with an oxygen and a hydrogen. So COOH, that's the kind of thing you're looking at there. So do you need to know what they look like? No. Should you be familiar with those terms? Maybe. It's one of those things that we used to talk about, and I think it's important that I spell them out because occasionally I use the terms, so I want to make sure that you guys know what they are. Hopefully there are no questions about that, but if there are questions, please let me know. We also need to be able to talk about polyprotic acids. And one of the things we talked about previously is that not all acids have only one proton. They have multiples. So things like carbonic acid, it's H2CO3, and so there are 2 protons that it can donate. When that happens, you'll see that there's a table like this that contains more than one K value. So we have a Ka for the first loss of proton, second loss of proton, and for H3PO4, a third loss of protons. Each one of them has a different contribution of H plus to that solution. And that's all based on the situation that exists. Okay. Is it possible to solve for that and find everything that you need to do? Yeah, absolutely it is. We'll talk about that in a second. So diprotic and polyprotic acids. Diprotic means it has 2. Polyprotic means anything more than 1. So usually we refer to that triprotic as 3, but polyprotic can be anything more than 1. Successive protons are weaker acids. So once I lose that first proton off of H2CO3 and it becomes HCO3 minus, that's a weaker acid than H2CO3 was. And that's because it now has a negative charge. So it's not as inclined to give up that proton. Okay, that's what happens with that. Now, can we do calculations on all these things? Oh, you bet we can. Absolutely we can. And here's an example from your textbook, okay? I'm only showing this to you for your own information. This is not something that we will do on a test. This is not something that you're responsible for. There's actually an entire class about how we make these calculations and why we do this, all right? So it is not important that you're able to do this kind of calculation, all right? It is important that you understand that we don't know exactly what that contribution from the second acid is without doing some work. And so we know it's going to be more than something, but not necessarily exactly what it's going to be. Okay? So that's what I want you to understand from that. I'm going to go ahead and zoom back out. So that's that part. So like I said, you will not have to do that. You may be asked for an overall K. And so if we had 3 steps and we had a K for each one, we might be asked for the overall K. We talked about that in the chemical equilibrium lecture. So you may be asked for that. But that's a very different thing than looking for all of those concentrations. Okay? So that's everything that we have in the acid information section. All right, I'm going to stop talking about the acid information. We're going to get ready to do some more hardcore calculations. I'm going to set up a new section to do that. So I'll see you soon.